Morning everyone. This is our session on division by paravartya method. Previously we have learned how to do division with respect to Nikhilem Sutra, but that is good only for large digit numbers. We dealt with digits like 88, 89, 97, something like that, which are closer to their base numbers. Okay. Now what to do if the digit involves small digit numbers? If we have small digit divisors? So now we go for paravartya method, which is very easy and comfortable for almost many methods. Okay, this is also a special case, but it helps us in many ways. So now let us learn this one. So if someone remembers Horner's process of synthetic division, this is the division method which we learned in algebra, which we already learn in algebra as a process of learning how to divide quadratic or higher degree equations and divide them as well. So now this helps in our paravartya method since it is a bit similar. Now let us see how to divide 12x square minus 8x minus 32 by x minus 2. So when we are dividing with x minus 2, we actually take this coefficient and we apply the method like x minus 2 is equals to 0. Okay. So now we reverse the sign of minus 2 and then we apply into it. We do multiplication exactly as same as of Nikhilem method, but there will be a small change. Now let us see how it is. See. Now we are taking this, we changed the sign of minus 2, we are taking it as 2, and so this 12 comes here and this gets multiplied into 2. So 12 2's gives us 24 and 24 minus 8 gives you 16. So 16 again multiplies with 2 and gives you 32. So finally what we get 12x plus 16 and this 32 minus 32 becomes 0. So now you need to observe that we have a x square term here and we have x to the power of 1 term here. So when you divide x square by x, what you get is 1 x term and 1 coefficient. So this 12x plus 16 is our coefficient. Instead this and this 0 is a remainder. So please observe this pattern properly so that we don't have any doubts in our paravartya method. Now let us see one more example of higher degree. So we are taking a big one, x power 4, and we are taking even a bigger divisor, x square. So what we do when in case of higher numbers like this is, here we have two coefficients apart from the first term. We are never going to consider the first term. Okay, this is this will help us regarding quotient. So these coefficients are minus 1 and minus 1. So we will take plus 1 and plus 1. So the coefficient of this term x power 4 is 1. So 1 into 1 and 1 into 1. So this get repeated as here like this. And here it is minus 1. Minus 1 plus 1 gets us 0. So the next two terms will be 0. We will leave one digit here and proceed till you reach the rightmost place. Okay, now 1 plus 1 gives you 2. So 2 plus 2. So now we add the coefficients of all the numbers. We get x square plus 0. So there is no x term here and the coefficient will be 2. And this will be our quotient part. And 5x plus 1 will be remainder part. Now we will come across one special scenario which will help us much further. So whatever divisors we had taken, so the coefficient of the divisor first digit was 1 in previous two cases. But how about you take other divisors? So what you will take is you can actually perform same with the method, but the steps and a bit complexity will increase. So that involves more time. But we need the simpler method in the case of Vedic mathematics. So our method becomes easier when we divide it with 3 and instead keep it always 1. In Nikhila method also, if someone observes, we divided and multiplied the divisor according to our benefit, and we did the same after we got the result. So now we got x minus 7 by 3, so we will consider plus 7 by 3, and then 3 into 7 by 3, that gives you 7. 7 minus 1, 6, and 6 into 7 by 3 gives you 14. So now you get 3x plus 6 and 14 minus 5, 9. And you remember we divided the divisor, so we have to divide the result. And one more thing what you need to remember is the remainder will never get changed. It will neither get divided nor get multiplied no matter what happens. And we are going to divide this 3x plus 6. So we are going to get it as x plus 2. And this is the quotient and 9 is the remainder. Now since we have understood all these things, all these three equations, now we will apply the same principle in case of paravartya method. So we are taking 1, 1, 2. So this is something like x square minus x minus 2, what we did earlier. So we will take these two digits, minus 1 and minus 2. I am trying to explain this. What will it happen when we do it with respect to Nikhila method? Previously we learned Nikhila method, right? We are taking its complement with respect to 1000. So that gives us this kind of procedure. And this is quite cumbersome and lengthy, and it involves a lot more time, and it is actually not worth it. If we see something like this, we feel like normal multiplication is far more better. Why should we go for Vedic mathematics? So now paravartya method comes into our help. So we are going to take 1 and 2, minus 1 and as minus 1 and minus 2. Since we are positive here, we are going to take it to change the signs and take them as negative. So this 1 comes here and minus 1 minus 2 replicate. 2 minus 1 gives us 1. So next step will be 1 and 2. Here it ends. So now whatever the result you got, so if we observe and compare it to the earlier equations, this will be coefficient x, x square, x cube, and this will be x cube, and this will be a term of x square. So what do you get? X plus coefficient. So the 11 will be our quotient, and the remainder will be this one. Okay. Sorry for my mistake. This will be 2 only. Somehow minus got added. Sorry for that. So now let us take some more examples. Let us divide 1, 2, 3, 4 by 160. So we are going to do it the same method. Minus 6 plus 0. Okay. 2 minus 6 gives us minus 4. So next step will be 24, 0. And now we are going to add all the things. So this method seems to be pretty good until we observe the same problem what we have observed in earlier Nikhila method. See, if you observe, this will be the quotient, and this 274 is actually more than 160. So what are we going to do? By our simple common sense, we can see that it divides once. So we are going to reduce 160 from it, and our actual quotient is 7 and actual remainder is 114. So whenever we get a remainder which is more than the divisor, we either divide it once again or we simply subtract the divisor from it. And let us also observe in what cases which method we have to prefer. See, here we have 1, 1, 2, 3. So we are taking all these three. We'll always leave the first one and we'll take all other numbers and we'll go change their signs. So since this is positive 1, 1 into minus 1, minus 2, minus 3. And 3 minus 1, it gives us 2. So next we'll go for minus 2, minus 4 and minus 6. So that will give us 1, 2, 0, 5 minus 7, minus 2, 6 minus 6, 0. So now what we can do? 1, 2, 3, 4, 5 and this is 4. So we will get one x term, one coefficient. So, sorry. But now we have one special case. What is that special case? Here we have minus 2 in the remainder. So whenever we get negative numbers in the remainder, we'll add the divisor and we'll subtract the quotient by one digit since we are adding the divisor once. So we are adding 1123 here minus 20 gives us 1103 as our remainder and the quotient will be 11. One more small simple case, and why are we taking it? So that we know how to go apply vinculum in it. Okay, so the 82 we can express it as 102 minus 20. So we are taking it as 1 minus 2 plus 2 and we change the signs, it will be plus 2 minus 2 and then this 103 1 comes before below here and it multiplies with 2 and minus 2. So when we add, we get 1 as quotient and 21 as remainder. It's not like you can't divide 103 by 82, but this is just to understand method. Now let us see how to do these divisions with respect to paravartya, vinculum, niculum and everything, so that whatever method sounds easy according to the number, you can apply that one. So 2341 by 819. This divisor seems to be quite large digit number. So its complement with respect to its base 1000 can help us much easier. Okay. So 2 comes here, 2 ones are 2, 2 8s are 16, 2 ones are 2. So that gives us 2, 5, 20, which is going to get carried on this side, 1 plus 2, 3. So now we have quotient 2, remainder 703. Now let us see how to include vinculum in it. We can write this 181 in terms of a number as in vinculum model. How we are going to write it? We can write 181 as 201 minus 20. So that gives you this value. So what happens, why we are going for this is, when we have high digits numbers like 8, 7, 9 and when we multiply it with our consecutive numbers, we get big numbers like 16, 20, 40, it can be much higher. So we are going to simplify it much in a way that we have nothing more than 1 or 2 and that can maximum give you 4, 6 or something. With numbers are much simple. So this 2 into 2, 4, 3 plus 4, 7, 7 into minus 2, sorry, no. So 4 minus 4, 0, 3 plus 4, 7, 1 plus 2, 3. And just like earlier, we see that we arrived at the same value. 2 is the quotient and 7 or 3 is the remainder. Now let us see how to apply the paravartya method we just learned and use it along with the vinculum. So now we can actually apply this vinculum to the number 819. And how are we going to express it? 1000 minus 200, which gives us 800 plus 20 minus 1. That gives us 19. Okay. So now you can see that we are going to take 2 minus 2, 1. And we are going to multiply it with this one. 2 into 2, 4. 2 into 2, minus 2, minus 2, minus 4. And 1, 2. So this process, don't you think it is much simpler? More than earlier cases, this paravartya method made it much easier. It's easy, like, it's just like a number play or game what you play on some phone. So now let us try to understand this method with the help of some more examples. So we are going for higher numbers. This is almost closer to 40,000 and this is closer to 10,000. Let us see. This is a large number. So we are taking purposefully large numbers here just to explain the difference between Nikhilem method and paravartya method. Okay. So this complement with respect to 1000 is 181 again. And we are taking 3 here. So we are going to multiply. Whenever you need to observe that whenever we are doing these calculations with respect to complement of divisor with respect to its base, then we are going to take whole number. But when we actually express this divisor in the form of vinculum or other number, we are going to consider only all the digits except the first one. So now we are taking complement, so we are multiplying it our whole 4 digits with respect to 3. So 3 into 0, 0, 3 ones are 3, 3 8s are 24, 3 ones are 3 again. And just add it up. And numbers get carried over. So finally we get something. And one more thing what we have to consider is, here 3 is the quotient. 10542 is actually the remainder. So now we can see once again that the remainder is more than the divisor. So what we will do? We will perform the division once again. We are going to add this number 0181 and we are going to, since we are dividing once again, we are going to add this number to 4 and we get the remainder as 723. So this number comes here and gets added. So you are not having any digit here. Here the remainder is 723. And we shall see one more, like how to express it in unicular method and see if we can make it much simpler. See, this is the method, like this is just to explain how to deal if the remainder is more than divisor in just another way, and how are we dealing with it. Okay, here we can either add the complement once again and we'll get the same result, or we can subtract the divisor as we did earlier. So basically these two methods are just one and the same. Okay, the difference with respect to this divisor and its complement is nothing but 1000. So you can hardly see any difference in its remainder. So, and we'll get a proper quotient. So please take these two things into consideration. Whatever comes to your benefit, whatever seems good, you can apply that method. And now let us see how to do the same problem with respect to paravartya and vinculum. Okay, so now we are going to express this 9819 in terms of 1000 minus 10,000 minus 200 plus 20 minus 1. Okay, so now as I had told earlier, if it is complement, you will take the whole, all the digits. But if we are expressing here divisor as this one, so we will take these 4 digits and we will leave out the first digit. And this red bar always indicates negative. So now when we are going to change the signs, that will become 0 plus 2, minus 2 and plus 1. So the 3 zeros are 0, 3 twos are 6, 3 into minus 2 minus 6 and 3 ones are 3. Now you can see actually things, the same value what you get is in a much simpler way. Okay, so now we got quotient as 3 and the remainder is 10542 again. And we do the same, we exactly do the process again. For this, we do the division in shorter terms only for this 10542, only for remainder. And we arrive at the same result. So basically whatever the method is, the beauty is we arrive at the same correct answer. So you just have to choose whatever suits your brain. And now let us discuss with one more example. 1111 by 839, sorry. So here why did we separate here? you must have observed 839 is closer to base 1000. So 3 zeros. So slash, separation comes here just for our benefit and so that we can understand it easily. And its complement is 161. So 161. That gives us 1272. So the quotient is 1. The remainder is 272. How to do the same thing with respect to vernicular? So the now 161 we define it as 200 minus 40 plus 1. So this comes 839 1211. Now we write it as 161 as 241 and you should remember this bar indicates negative. So we are taking this value plus 1 2 1 minus 4 gives you minus 3. 1 plus 2 gives you 3. So the remainder is 302 minus 30. You have to notice we have a bar over third digit. So that gives the actual remainder, that is 272. And we have also tried writing 839 in terms of unicular number. That is 1000 minus 200 plus 40 minus 1. And also I have told you when we are taking the divisor itself in unicular number, we will do the same as that algebraic equation. So we will exclude the first number and we will go for 2. This sign skate opposite, minus 2 becomes 2, 4 plus 4 becomes minus 4 and minus 1 becomes plus 1. So now the process became really easy. See. Thus 302 minus 30 again. So that gives you 272. One more example. How to divide 1356 with respect to 182. So here we are taking minus 8 and minus 2. And 13 minus 8 minus 2, since the digit is 1 here. And 3 minus 8 becomes minus 5. So minus 5 into minus 8 becomes plus 40. And minus 5 into minus 2 becomes plus 10. So we got 5446. And we got quotient as one. Now here what we need to observe is this 446 is actually more than 182. So we can perform the division once again. So we are going to perform division for only 446, which involves we are leaving place here again. So 4 into minus 8 minus 32, 4 into minus 2 minus 8. So that gives you quotient as 9 and the remainder is minus 28 minus 2. Now if we remember the earlier problem, we can see that whenever you get negative number in remainder, so we are going to add a divisor. So this is minus 282. So we are going to add 2 times the divisor. So that becomes 364. Since we are adding it, we are going to reduce the quotient. So now the quotient will be 7. The remainder will be 82. And this is how we do it with the help of only paravartya method. Now let us actually simplify the process. How? We are going to write 182 as 200 minus 20 plus 2. And what we are doing is earlier we have got the big large digits. Why? We have the higher number minus 8. So instead what we will do is we wrote it as 2 minus 2 plus 2. That itself got simplified. But we are going to divide it once again so that this first part, if it becomes 1, it will help us to do the calculation much more easier way. So that becomes 1 minus 1 plus 1. So we are going to consider only 2 digits since we are dealing with the main divisor here. 1 plus 1 minus 1 becomes plus 1 and plus 1 becomes minus 1. Now we can see that this 1 multiplies with 1 and minus 1 and they repeat, and 3 plus 1 gives us 4 and 4 into plus 1 gives you plus 4 and minus 1 gives you minus 4. So now you are going to get this 1482. But remember we have to divide when you divide the divisor. So we divide this quotient, we get it as 7 and we get the remainder 82. And if someone gets a doubt why we should divide only 14, see, the 182 is closer to 100. We can take 100 as base. Since we can't take 1000 as 2, this term is too far from 1000. So if we take 100, then only 2 digits we can consider on the right side of our answer part. So this 82 will be our remainder, and whatever is the remaining on the left side is our quotient. You can see how simpler it became by doing this division with respect to paravartya method. Now let us see one more example. 1700 by 223. I mean 1699 by 223. So we are dividing it divisor so that it gives us 1 half. So what to do when we get these fractions? So don't worry, even if we get our fractions, it will be still much simpler method. Okay. So this -1 and -1.5. So 1 into the same thing. 6 minus 1, 5. So 5 into -1 minus 5 minus 7.5. So if we add, this becomes, quotient becomes 15 and the remainder part becomes 2.5 plus 1.5. Now you don't have to do anything with respect to remainder half, but how to deal with this calculation, that we are going to learn it here. So now this 7.5 quotient refers to our divisor. So what we'll do is, let us see, half of 223. Thus 20 into, see, this is our quotient 7. So this from this half everything goes for remainder. Okay, this half refers to our divisor, so half into 223. But here on we will take their units place into consideration. This half refers to divisor, half into 223 plus 2 into 10. This is tens place, so that gives you 20, and half into again tens place, that gives you 5 plus 1.5. So that exactly gives you 1.5 plus 20 plus 5 plus 1.5. So that gives you actually 138. So this is how we calculate in terms if we get fraction at any time. Okay, so this is just to indicate what if we get fraction when you divide the divisor. So one more method is we can multiply. We can both divide and multiply the divisor. So 4 into 223, that gives you 892. And 892 seems to be much better if it is expressed in funiculum. Okay, so we are going for 1000 minus 100 minus 10 plus 2. So this gives you much easier fraction, 1 minus 2, and that gives you 1807. But since we have multiplied by 4, we are going to multiply this quotient also by 4. And we got this remainder 807. So now what we are going to do? We need to consider, don't get bothered that this 807 is less than 892. No, our actual divisor is 223. So we have to take this into consideration. 807 is greater than 223 by thrice. So we are, subtracting the product of 3 into 223 and we are adding 3 so that we arrive at the proper quotient 7 and the remainder is 138. And if you want me to mention this, we are expressing our divisor in terms of funiculum. So we excluded the first part and we are taking all the remaining things with their signs changed. See, so now this process, it looks much simpler because we took it in terms of funiculum and we took it everything in terms of simple digits. So this is how you do the calculation. Whatever suits you, you can consider it. Here in this presentation, we have taken all types of special examples of all cases that can be covered here, so that you don't have to refer anything else. So now we are multiplying 7685 by 672. Okay, this 672 we are going to divide. This number seems to be quite high. So what happens if we divide? Still it is 328, and we are going to get something like 21. Sorry. So this 328 we are going to get it as, express it in the terms of unicolumn as 300 plus 30 minus 2. Okay. So 7 3s are 21. 7 3s are 21. 7 minus 2 minus 14. So the quotient is 7 and the remainder is 2981. And 2981 is quite high. So we are going to do is once again. And how many times we are going to do? We are going to do the same operation for 2981. So since here the number is 2, 2 into 3, 2 into 3 and 2 into minus 2. So we are going to get, and since we are multiplying with the help of 2, we are adding it to the main divisor, quotient, and 7 plus 2 becomes 9, and this results in 1631. Now here we can see it is still higher in number. So we are going to do twice once again. So our main divisor is 672, and if we multiply it twice, you get 1344, and you can easily get 11 as quotient, 293 as remainder. Now let us see how to do it in much simpler way. See, if we suppose divide the divisor much further, if you here what you did is we took its complement, right? 672's complement with respect to base 1000 is 328, and we did it almost unicolumn plus unicolumn method. So how about we divide the divisor? So you get 336 if you divide by 2, but you get numbers like 21 and something because 3 is involved. So anything, this first digits of both divisor and dividend are important. So that gives you 21 type of number. We can also divide it by 4 times, which we get 168, but we again have this higher digit 8. So we may get, there is a possibility of getting higher numbers, and if we divide it by 6 times, we get 112. This looks much simpler since we don't have any bigger digits, we have only 1 and 2. And we can also divide by 8, and we can divide by 84 as well. Okay, now let us pick one number which is much simpler and try to do with our division with respect to this number. So this becomes simpler, minus 1 and minus 2, and 7 into minus 1, 7 into minus 2, that becomes minus 14, and 6 minus 7, minus 1. So the minus 1 when it gets multiplied, it gives you 1 and 2. So the highest number what we can get here is 14. See, compared to earlier, we arrived at much simpler numbers, but we got negative here. So whenever we get negative, what we do? Let us keep it remainder separately. We'll calculate it again. This 70 minus 1 gives you 69. So we are going to divide with 69 for a proper coefficient, and this is the remainder part. Okay. So when we divided 69 by 6, that gives you 11 and a half, and this is the remainder part. Now how to calculate this one? We have seen one problem earlier also with respect to fractions. So this half goes on the remainder part, and here our quotient is strictly 11, and half refers to divisor. Which divisor it refers? It refers to main divisor 672 always, and this goes for its tens place. So it is minus 50 plus units place plus 7. So that gives you remainder as 293. one more number, one more example. Now this is also some special case. Let us see how it is. So we are dividing this 23 into 4 times to make it 92. Okay. This 23, if we want to perform this division with respect to Nicola method, it is really difficult since the number is far from its base. Its complement gives you 77 and that only complicates things. Now let us see how to use it simply with respect to paravartya method. Now we are going to write this 92 in terms of much simpler vernacular method so that we are remained only with ones and twos everywhere. So the highest number can be 4. Okay. So 100 minus 10 plus 2. And we are going to take 1 minus 2 here. So 1 into 1 into minus 2, 1 minus 2, 0 plus 1, we got 1 again. So the highest number can be 1 and 2 here. So now we get 1, 1, 0, minus 1. And we remember since we multiplied divisor, we also have to multiply this result. So 4 into 11, we get 44. And here we have negative number in the remainder part. So what we are going to do, we are going to reduce this quotient by one number and we are going to add this divisor 23. Remember we have to always add, multiply, divide our actual divisors. Okay, that gives you 43 as quotient and 22 as its remainder. So now here is the session, guys. Thank you for listening and I hope this is helpful, and if I falter somewhere or if you get any doubts, please feel free to comment in the below comment section. Thank you again.